everyone. In this lecture, I will explain the inverse Z transform part 3. Uh, the first problem is the Z transform of a sequence x of n is x of z equal to 1 plus 1 by 4 into z inverse 1 divided by 1 minus half into z inverse 1 into whole square. Here ROC is modulus of z is greater than half. That means we have to use right sided sequence. That means u of n, unit step signal. Here x of z equal to 1 plus 1 by 4 into z inverse divided by 1 minus half into z inverse whole square. That means x of z by z equal to z plus 1 by 4 divided by z minus half into whole square. Now we will take the partial fraction. If we perform the partial fraction, then we can find when z equal to half, then b equal to 3 by 4, that means 0.75, and equating the coefficient of z on both sides in equation 1, then we get a equal to 1. That means h of z by z uh, equal to 1 by z minus half plus 0.75 divided by z minus half into whole square. That means h of z equal to z by z minus 0.5 plus 1.5 into 0.5 into z divided by z minus 0.5 whole square. This is equation 2. Let this equation 2. If we take z transform of a to the power n into u of n, then we can find z by z minus a, and because ROC is greater than a, that's why we used right sided sequence unit step signal. That means z transform of 0.5 to the power n into u of n is z by z minus 0.5. If we take the inverse z transform, then we can find the previous function. That means for this portion, the inverse z transform will be 0.5 to the power n into unit step signal, and now from differentiation property, n into 0.5 to the power n into unit step signal, if we perform z transform, then we can find minus z into ddx of x of z. Here z transform of this part is z by z minus 0.5. That means the final result is n in z transform of n into 0.5 to the power n into u of n is 0.5 of z divided by z minus 0.5 whole square. That's why the inverse z transform is n into 0.5 to the power n into u of n. That means this is the second portion of equation 2. this part, second portion. That's why taking inverse Z transform at both sides in equation 2, then we can find the inverse Z transform is h of n is 0.5 to the power n into u of n minus 1.5 into n into 0.5 to the power n into u of n. This is the answer. Another problem is find the Z transform of yn equal to n square into unit step signal. Let x of n equal to u of n. The Z transform of x of n is x of z equal to summation of n equal to minus infinity to plus infinity x of n into z to the power minus n. Here xn equal to un, and the Z transform of x of n is 1 by z minus 1. But here the function is n square into unit step signal. The Z transform of unit step signal is z by z minus 1. From differentiation property, n square into x of n equal to z square into dd double derivative of x of z. X of z is z by z minus 1, and the first derivation, here side doing first derivation, and secondly I have performed the second derivation, and finally the result is 2z square divided by z minus 1 to the power 4. Here yn equal to n square into unit step signal, and unit step signal is x of n. If we perform the Z transform of yn, then we can find y of z. So that's why the final result is y of z, and y of z equal to z square divided by z minus 1 to the power 4. Here's I ending my lecture. Thank you.